This is 8C.1b, which is called Applying the Law of Sines, day 2. So it's kind of like where we now know how to use law of sines when we don't have a right triangle, but there are some specific cases that we're going to see today called the SSA case, and learn about the area of any triangle when it's specifically an SAS. So we're going to start with the area part first, and then we'll move into what do we do when there's a special case called the SSA case, specifically when working with law of sines. So here's the beginning part with the area of a triangle for SAS. So when you're given any triangle, and you know that usually when you do area formula of a triangle, it's 1/2 the base and the height, but that only works if you have a base and a height that would make a right triangle, a right angle when you have a base and a height. This is saying instead that the area of any triangle would be given by 1/2 of the product of the length of the two sides, and then you have to multiply the sine of their included angle. So if you think back to what you just saw with SAS, that's essentially what we're saying here. It's two sides with their side, the sine of the included angle, which is kind of like an SAS scenario or case. And so when I look at each of these, these are all three different ways of writing the same formula because it's based off of each of the different angles, either sine of A, B, or C. So when I look at my first one here, angle A, here's angle A, is using sides B and C. Remember that the lowercase letters are representing the side lengths. So it's saying that this side B with C and that its included angle, that's why it's an SAS, that could be used to help you find the area of this triangle. Now you could also instead use, and I'm going to switch here to a different color, so you could say angle B and use its included two sides. So that would be C and A. These are A and C. That's what that says, AC. And then finally we get to the last scenario for angle C, and that would be side A and side B, which is again what it's saying right here. Okay, so now that we know a little bit about what the formula is, let's go ahead and practice it to be able to help us find the any kind of area for a triangle, as long as it gives you two sides and an angle where the angle is included. Just make sure that your angle is always included between those two sides. So here's the scenario. You are setting up a triangular flower garden in your backyard. If you lay off lengths of 15 feet and 11 feet. So those are your two sides of this triangular garden. So if I try to draw this out, there's 11 feet and then maybe a little bit longer here. This is 15 feet. And again, it's a triangle, so I can continue it like that. And from there, it goes on to tell us for the two sides of the garden with a 62-degree angle between the two sides. So this has to be 62 degrees. And it goes on to ask us, what will the area of that garden be? Well, it's as simple as realizing I have an SAS scenario here. So it doesn't really, we don't need to kind of label it with the letters A, B, C, and so on, because I don't have that in the diagram. Instead, you can kind of just think of it as 1/2 times a side times another side times the sine of the included angle. Okay, so we're going to go ahead and plug those numbers in, substitute them in, and simplify until we have the final area. So this would be 1/2. It does not matter which side put first or second, they're just being multiplied together. So there's the 11 and the 15. And then the sine of the angle that was included, which is 62 degrees. Okay, so I grab a calculator here and try to type this whole thing in. This can be in parentheses also. So you can do 1/2 times 11 times 15 and times the sine of 62 degrees. Make sure you're still in degree mode. I'm going to double check my calculator is. Okay, and then when I hit enter here, we do get 72.8. It does not specify how to round, but we can do about tenths here. And the units here should be in feet, or feet squared, because you had feet times feet, square feet. Okay, so the final area for this triangular garden is 72.8 square feet. Okay, now there's a U-try right next to it, shows you the triangle, shows you the SAS scenario. So go ahead and try this. If you can pause the video here to try this example out, and then I'll put the answer here so you can see the correct answer. All right, hopefully you had a chance to try that out. For the U-try, it's just using the two side lengths, 2.3 miles and 1.4 miles that were created by these three roads, and then multiplying by sine of 78.1 degrees, grabbing a calculator, typing the whole thing in, and seeing what it comes out to. And this final answer should be approximately 1.6. And the units here were in square miles. So that should be the final area for this example with the bordered three roads. Okay, so now just want us to kind of go to this point of where we were in the previous lesson with realizing that when we have non-right triangles, we can't just use our regular right triangle trig like using sine or cosine or tangent, because we don't have like opposite and hypotenuse, because in a right triangle, in a non-right triangle, you don't have a hypotenuse even. So you can't use regular right triangle trig that you've been doing before with a triangle that's not. And so the following examples that we're about to see are not going to be right triangles, and we're going to need to decide the best way that we should solve them. We won't actually do all of them just yet. We're just going to be deciding which, based on the information given, what option can we use. And so on the previous lesson, you did learn about law of sines, and specifically you can use law of sines when you are given two angles and the side. So it can be either the included side or not the included side. That's why AAS or ASA work just fine for those. But again, that's going to be when you can use law of sines. Or it would be two sides and the angle that's opposite of those two sides. So like the angle cannot be included in those two sides. This instead is an SSA scenario. And so we're going to see more of like how to deal with or how to actually solve those later today. But right now it's just a matter of identifying, looking at the triangle, what information do you have, and then being able to decide, is it one of these three? So if it's AAS, ASA, or SSA, you're going to pick law of sines. That's the best way to do that. Or you're about to learn about law of cosines in the next lesson. So you would use law of cosines when you're given three sides, like an SSS scenario, or two sides and their included angle, which would be SAS. Okay, so those are our choices now. We have to pick between law of sines or law of cosines just based on the information given in each triangle. So we're going to go through these examples looking at, is it which sides or angles do we have here, and then once we can pick one of these five triangle congruences, the AAS, ASA, SSA, or SSS or SAS, that's when we'll decide then, is it law of sines or cosines. So looking at our first example, I have a side and I have a side. And the angle that's provided is in between the two sides. So this one would be an SAS because it's included within the two sides. It's actually touching both sides. That included angle would have to touch both sides, and that's why this is an SAS. And if we look up at the top here, SAS was for law of cosines. Okay, let's try another one. This time we have an angle here, that 57-degree angle, but then this side does touch this angle, but this side here does not. And so when this cannot be the same scenario as number one, because that was an included angle, this angle is only touching this side, not this other one. Whereas if I was to try to draw out this angle here, you can see it was touching both of those sides, which is what happens when it's an included angle. So this cannot be SAS. Instead, this is SSA. And if you look at the choices for SSA, that's going to be law of sines. Okay, the next one, we have an angle with 51 degrees, but then another angle. So we have two angles here. And the side that we have is not included, like it's only touching one of the angles, not both, but it's okay because both of these two angle ones are up here for law of sines. We just have to decide which one is it. And so since the side is not touching both angles, we would say that this is a law, it would be AAS. And then for the law, it says up here that this is law of sines. here's the next one. We have an angle and a side that is touching that angle, but this other side is not touching that same angle. So this one is not, the angle is not included between the S and the S, so similar to what we did here. This is an SSA, which we know is law of sines. Okay, and then a few more here. These just give us sides. These are kind of the easiest example, because when only sides are given, that's an SSS, which has to be law of cosines. Cannot use law of sines when we try to solve that triangle. All right, and finally the last one, we have an angle, a side, and another side. So again, same kind of scenario here where this angle is not included between the two sides. So this one would be SSA again, and then this would be still law of sines. All right, we have a few more on this next page. So number 7, 8, and 9, same kind of thing. We're just starting with or what information is provided, how many sides, angles, which ones are included or not, and then deciding is it law of sines versus cosines. So this time, again, an angle. This angle is only touching one of the sides, not both. So this is another SSA. Because the angle is not included between the two sides, that's still law of sines. And another one, we have this angle here. It happens to be an obtuse angle, still same thing. We're still applying, deciding is it which of the two options here. But this is a side, another angle here, and an angle. So we have two angles and a side. But because this side is not included between those two angles, this would be an AAS. And then we saw on the front page that that would be law of sines. All of the ones that have two angles and a side, which was either AAS or even an ASA, those were both law of sines along with this SSA that we keep seeing. All right, and finally one more here. There's an angle, but this angle only touches one side again, so this is another SSA, and that would be, again, law of sines. All right, so moving ahead now into kind of focusing on the SSA case specifically. So we've seen all the different options with the triangles, but we're still working with law of sines. And it says here, caution needs to be exercised when using the law of sines in the SSA case, however, because depending on the relationship between those two sides in an angle, sometimes you're going to see no triangle, one triangle, or two triangles that are actually possible. And the diagram won't show that. That's just something we need to be able to come up with based on some, let's try to figure out how we're going to decide that. So in order to help us decide how many triangles are going to be possible in an SSA case, and again, this is specifically only for an SSA case, if the angle that you're given is an obtuse angle, like we saw one up earlier here, some of the other ones may have been obtuse as well. Well, in that scenario, you have to first of all make sure that the opposite side is bigger than the other side that would be given, because you're going to have two sides given to you in an SSA scenario, but the angle that should be across from the obtuse angle on the side that's across from it, that side should be bigger. And so here's what happens. If the side opposite that obtuse angle is not bigger, it's actually smaller than the other side, then there's no triangle, because what you're stating is not correct. If you kind of remember from geometry, we always would look at the smallest angle had to be across from the smallest side, the largest angle had to be across from the largest side. They all kind of would match up like that. And so what you're doing is kind of contradicting, where you're saying the opposite angle is obtuse, well then the side across from that obtuse angle, which should be the largest angle, is no longer the biggest. Okay, so whereas here's what happens if the side opposite the obtuse angle is larger, like we said, then there would be one triangle like we expect. So remember, our choices were no triangle, one triangle, and two. We haven't seen the two yet, but now we have an idea of when it can be none versus one. And now we move into acute, because that was obtuse. Now acute angles, because remember, we're not working with right triangles. We've already done that. Specifically for acute angles that are in the SSA scenario, we have to be extra careful too. Because if you ever get a domain error in your calculator, then of course that would just mean no triangle. right? The calculator is literally telling you, nope, you can't get an answer for this, so there's no triangle possible. So those tend to be the easy ones. And then because we kind of have to think about our scenarios back from when we have to think about when sine theta is positive and which quadrants would it be positive or not. Okay, so here's my quadrant I'm going to draw over here. I have 4 quadrants. And technically, if they give us an angle, our choices that they're going to give us an angle in would be, like, let's imagine we're in our first or the 4th quadrant. But when we're in these 2 quadrants where sine is positive, you know that in a triangle, you're not going to get a negative degree answer. But we have to kind of think about what given angle theta would be. So let's say I'm given angle theta to be like this. Let's say that's theta. And I want to then work with what my possible choices are going to be. So we know that sine theta is possible in quadrants 1, or is positive in quadrant 1 and quadrant 2. And so in order to figure out where that's going to be, because quadrant 1 would be here and this is quadrant 2, imagine like if I was to draw this here. These 2 possibilities, if I'm working with this angle, any angle in these 2, we would have to check if the supplement of the angle that's sitting right here can be used to form a triangle with. Is it possible to form another triangle? Because we would have one triangle already just from the sine theta, but we would need to see, can we have a second one or not? And so what we're doing here is we're going to take the supplement of our quarter 2 angle, or I'm sorry, quadrant 2 angle, which would be right here, right? So we have quadrant 1, this is 2, if you want to use Roman numerals you can, this would be 3, and this is 4. So we're going to be trying to figure out, based on when we know this theta already here in quadrant 1, we're going to try to figure out that quadrant 2 one by taking the supplement of theta, which will get us that quadrant 2 angle. And then you're trying to decide, can I have a second triangle with it or not? And so the quadrant 2 angle, remember if it's the word supplement means I'm going to take 180 degrees and subtract the theta, the given theta that was there. And when I do that, it'll then help me decide if I can have a second triangle be formed or not. Because here's how we would calculate that. We would take your found quadrant 2 angle, which is how we just said how we're going to find that. We're going to take 180 and subtract theta from it to help us find that quadrant 2 angle. And in addition to that, we're going to add the original given angle that the problem would give you, not the one that you found on a calculator to get your theta, but this is the original given angle for your SSA, the A that was provided. So we have these 2 angles. If we add those 2 angles together, we have to make sure that that's less than 180 degrees to form a second triangle. So that's how we're going to make our decision of is it going to be possible or not. Okay, so we're going to actually go back up to all of the SSA cases to try to decide, is it 0 triangles, 1 triangle, or 2 triangles? Specifically with obtuse angles, you're only going to have 2 choices to pick from, no or 1. But with acute angles, we have to decide, is it no triangle if the calculator is giving me a domain error? Is it 1 triangle when you're just given a theta and it doesn't, this scenario doesn't hold true, where when you find these 2 angles and add them up and the answer is not less than 180, then we'll have to work with that. So we're going to go back up to examples 1 through 9, try and determine how many triangles are possible. And remember, we're only checking the SSA cases in which to decide if they have 0, 1, or 2 cases or triangles. Right, so anything that is not an SSA, we're going to know is just 1 triangle. So that first one, number 1, is an SAS. That would just be 1 triangle, because we don't need any special rules to check SSA. We're going to come back and look at all the SSAs together. So this is, again, just 1 triangle for AAS. Another SSA we're going to come back to. This is an SSS, so we have, again, just 1 triangle. And another SSA we're going to come back to. And then finally, on that last page, there was 1 more AAS, which would just form 1 triangle. Okay, so now for the SSA scenarios to decide, we're going to follow our rules. The first one that we have here is an acute angle. 57 degrees is acute. So if you're looking at the second rule that we had here, it says if the angle is acute, then we need to be careful. We're looking for, is it no triangles, one triangle, or two triangles in number 2 right here, following the rule. Okay, so on to number 2 here to decide if it's going to be 1, 0, or 2 triangles, because that's what it works for acute angles. We're going to set up our law of sines that you saw on the last lesson. So law of sines for that 57 degrees would be sine of 57, and then the side across from it, which is 30, set equal to, we don't have another angle here, so it would be this angle that's across from this 32. So we can call it sine A or whatever capital letter you'd like to use here, with 32 across from it. Then we're going to cross multiply. So this would be 32 sine of 57 equals 30 sine of capital A. And then we would divide by 30 to try to get sine A all by itself. Okay, and this is where the calculator comes in. We would type all this in, 32 sine of 57 divided by 30. It comes out to this decimal answer. And I'm not going to actually write the answer there because you're going to go ahead and take the inverse sine of it because we're trying to find the angle. Well, I'll just write 0.895. And then the inverse, sine inverse, let's figure out what angle we're working with. So it looks like the measure of angle A is 63.5 degrees. Okay, so if my angle A is 63.5 degrees, now I have to decide, so it definitely worked. There was no error message, so there's definitely one triangle possible as of right now, but let's see if 2 is possible by following the rules that we said that we have to check to find our quarter 2 angle. We have to then add that to the original given angle to see is it less than 180 degrees, because so far I just have this angle and now I have to check the quarter 2 of this one. So quarter 2 angle, put that up here, would be 60 or 180 degrees minus the 63.5. So if we subtract 180 or 63.5 from 180, we get 116.5 degrees. That's our quarter 2 angle. And so now to decide if it's going to have the 2 triangles, we're going to take this 116.5 and add it to the angle that was given, that 57 degree angle. If these 2 angles together are less than 180, then we'll have 2 triangles. So let's see what we have. 116.5 and add 57 to that. When I combine those two, you get 173.5, which is definitely less than 180. Okay, and that's how we know then that this is going to be 2 triangles. Okay, if we look ahead to some more of these examples, we can see the same idea for, this is an obtuse one, so let's try this obtuse. For obtuse, it's a little bit simpler because now you just have the 2 options are no triangle or 1 triangle, depending on the opposite side being the larger side or not. And so if I look at this 104 degrees and the opposite side to that is 25, which is greater than this 18, that's not across from it. So this one would be 1 triangle. So we can do 1 triangle from that one. There's another acute angle here, so let's see what happens with this one. So we are taking that given angle and setting up law of sines with it. So sine of 50 degrees over 2.8 would be equal to sine of angle, let's call it angle A, over 4. Cross multiply and solve until you have an angle there, and then you'll find that quarter 2 angle again. So we're going to have 4 sine 50, you're going to divide it by 2.8, so that we would find out that sine A is 1.094, and then take the inverse of that. Oops. And this time it gives you an error message. As soon as I type in sine inverse of 1.04, which is what I had here, if that's giving you an error message, then there's no triangles possible. And we don't have to go on to find like a 1/4 angle or anything else. Okay, and then finally, the last two up here, we have another acute angle, and then finally another acute angle here as well. I'm gonna actually write down what the number of triangles you should get for each of these, because you can try both of these out and see if you do get the same answer. So this one here is another acute triangle, and so when you set up the law of sines on this one, you do get another domain error once you try to take the sine inverse, which means that this is one triangle. I'm sorry, no triangles. And because that was acute, that was the case. The last one that's acute, this one does end up getting us an angle, and you have to do the 1/4 angle plus the given angle, and it comes out to be less than 180 degrees. So if you do want, you can go over that with Ms. Wysocki when she gets back. All right, so those are the answers for those. Finally, at the very bottom, we have, we're just gonna try number 10 real quick. Sketch the triangle and then just decide how many triangles are possible. So here is my triangle, ABC, 40 degrees. Across from that, because lowercase a would be 13, lowercase b is 16. And now we just want to set up what's possible here. So this is an angle, and then two sides that are not included. So this is an SSA. It is an acute angle with the SSA, so you know your choices now would be if you're getting the domain error, that's no, when we set it up and you get no triangle in that scenario, or we're gonna have to check and find the 1/4 angle if it is possible. So this would be sine of 40 degrees divided by 13 equals sine of, we have to do capital B because it's across from the 16. You would find your angle B now. So in your calculator, you're typing in 16 sine of 40 and dividing by 13 to find out that sine of capital B is 0.7911, and then take the inverse sine of that. All right, and then we're taking the sine inverse of that. So this would be 52.3 degrees. And then again, you're going to try to find that 1/4 angle, because this one did work. So to find the 1/4 angle, you're doing 180 minus that 52.3. And then you're trying to add that to the existing 40-degree angle that was given to help you decide, is it less than 180 degrees? That definitely would be less than 180, so we'd have two triangles possible. So you can try out that last one, and then if